Hello everyone. Today I will be demonstrating about polyphase system. So first question, what does polyphase mean? So here this poly means multiple because mono means one, di means two, tri means three, and similarly poly means multiple. So in case of polyphase system there could be multiple phases. So this this could be two phase, this could be three phase, four phase, and so on. So whenever there is multiple sources with different phase angles, we call that system a polyphase system. So let's say in this example we have a sources where the first phase E1 is giving 20 angle 0 degree. That means 20 volt is the magnitude and 0 degree is the angle. And similarly E2, that means another second voltage is generated whose phase angle is 180 degree but the magnitude is same as E1. So this is an example of two phase system. Similarly, if we consider three voltage E1, E2 and E3 and all have the same magnitude but they have different phase angles, we can call it a balanced three-phase system. So why three phase? Since it has three phases E1, E2 and E3, they have same magnitude as it is written 220 volt, let's say, but their phase difference is different. So these are two examples of polyphase system. One is two phase and another is three phase. And in our course we will mostly focus on three phase system. And in power transmission, generally three phase conductors and three phase systems are being used. So question arises, why do we use three phase system? One of the main reason is whenever we want to transmit power in three phase system, then we generally need thinner conductors. But if we want to transmit same amount of power in single phase or two phase system, then the conductor diameter will be higher. And you can understand that whenever the conductor diameter will be higher, necessary cost will be also increased. That's why we want conductors to have thinner diameters, that means thinner conductors. So that's why three phase system is more preferred. Another important logic is large motor, that means three phase induction motors. We generally use this. Why? Because there are two types of motors, probably you will read in later courses. So three phase motors, they are generally self-starting, whereas single phase induction motors, they are not self-starting inherently. That's why we generally prefer three phase system. There are other advantages as well, so I think you will study those in power system courses, so don't worry. So in this lecture we will mostly focus on three phase analysis. So first of all, three phase generators. So let's say these are three phases that are being generated in a generator. So let's say we have three phases, just like this one and this one. So if we want to have a Y connection, then we can combine this three portion at one end and other three portion, let's say this one A, this one B, this one C. So we can also draw this just like this shape. That means it looks more like a Y. So this is called Y connection, and also there are delta connection we will observe. Let me show it first, this one. So this is three phase generator, mostly Y connection here. So these are three voltages. One is EAN, another is EBN, another is ECN, and the 3 points is shorted here. This is the neutral point, we say N, and these are three phases A, B, C. So the voltage generated, let's say this one EAN, the general expression of any voltage, we can say it has some magnitude and it has some phase angle, and in time domain we write it magnitude then sine of omega t. So that in phasor domain we can write it EM over root 2 then angle 0 degree, since it has no phase shift. So this is a common expression. And secondly, let's say this is already written EAN and the second phase EBN. So you know that we have total angle of 360 degree. So if we displace them in 360 degree, since we have three phase, so we should have displacement of 120 degree. That's why our second phase, here we have given a phase shift of 120 degree. So this is the second phase, it has same magnitude, that is EM, and the phase shift is minus 120 degree. Similarly, our third phase, which is ECN, same magnitude, and the phase shift, previously it was minus 120, now it is minus 120. Again we have another minus 120, since we are giving 120 degree displacement between two phases. So now it returns as minus 240. And you know that minus 240, this can be also written as plus 120 degree as well. Since total angle is 360, so 360 minus 240, it will give you just plus 120 degree. So you can write this as well. So let me clear this all. So these are common expression in time domain. So we have three phases, the expression I just explained. So if you want to draw them in wave shape, so this could be just like this. So EAN, you know that it was just EM sin omega t. So no phase shift, that means it started from the beginning, just like this, no phase shift. The second one, it has minus 120 degree, that means it will starts its point at 120 degree position, right? So here from this 120 degree it has started its journey, just like this. And the third one, which is minus 240, so at an angle of 240 degree it will start its position. And also you can write it 120 degree, so you can understand that if I extend this in this direction, let's say, so obviously this should be our 120 degree position. So this is minus 120 degree position. So this is just the expression of ECN. So these are just the drawing of these three phases in a graph. Let me clear this all. Now in phasor notation, so I already mentioned you that the first one, it should be EM and EM over root 2, because we generally use the RMS form whenever we want to write the phasor form. So that's why the first one is EM over root 2, then angle 0 degree, and the second one we have an angle minus 120, and third one minus 240. And also you can write it as plus 120 as well, because it is similar. And another thing, this EM over root 2, we can write it as capital EAN. That means capital EAN, this is just the RMS component, EM over root 2. So similarly, for this second phase we can write it EBN, and for third phase we can write it ECN. That means these are the magnitude. And also if you notice here, these are the phasor quantity, right? So phasor quantity has this is the magnitude and this is the phase. So phasor quantity has both magnitude and phase, and since all are E, so to differentiate among these, so we have used this sort of explanation, EAN, for phasor quantities, and just simply E as for magnitude. So whenever you understand that whenever you have a vertical bar, so these are the phasor quantity, that means vector quantity. In mathematics probably you notice that we have sometimes we have bolded just like this. Also sometimes we put a horizontal bar to represent vector quantities. This is just like this. So now if you draw the phasor diagram, so this is the reference voltage, this one EAN, which has angle 0 degree, that's why this one just like this. And the second one, this was minus 120 degree, and you know that the clockwise direction is the negative direction, negative angle, and anti-clockwise is the positive. Since it has a negative angle, that means we will move to clockwise direction, so this direction. That's why this one, that is EBN, this is shown here at minus 120 degree angle. So since the direction is clockwise, that's why this is basically minus 120 degree, and this one actually minus 240. So already minus 120 degree given and another minus 120, so now it is, I can say, minus 240 degree. And you know that we can write minus 240 degree as plus 120 degree again. So if you write it, so this is the plus 120 degree. So this is just the phasor diagram. And another thing, that the phasor sum of these three phase voltage is 0. So why this? Because let me clear it first. So all these phasor quantities has same magnitude, obviously, because I have showed it at all are em over root 2, right? So all have same magnitude and they are displaced by same amount of angle, that means 120 degree. So in mathematics, I think, or in physics, you already know that whenever three vector quantities or three forces are in same displacement and same magnitude, then the resultant will be just 0. So these are the phasor quantity, not just voltage, not just angle. So the phasor quantity, since they are all summed, so the resultant will be 0, since all has same magnitude and same displacement between them.